Chapter 1, Equations, Inequalities, and Mathematical Modeling. In Lesson 1.1, we'll look at graphs of equations. We'll sketch graphs of linear equations and identify x and y intercepts. Determining solution points is how we'll start. A solution point of an equation, AB, when substituted in for x and y in an equation, simply makes the equation a true statement. What you'll get is a point to plug in, and you'll answer yes or no. It's pretty easy. I do need you to change the equation though, otherwise it doesn't work for either one of them, and that's unfortunate. Please make your equation y equals 10x minus 7 instead of plus, and then we'll determine if a point lies on the graph or not. Given any coordinate, substitute that point in for x and y. That would give us 13 equals 10 times 2 minus 7. Well, 10 times 2 is 20, and 20 minus 7 is in fact 13. That's a true statement, therefore yes, that point lies on the line. Trying another one, same idea. If we substitute in negative 3 for y, oops, not 2, sorry about that, and negative 1 for x, now we have 10 times negative 1 minus 7 would give us negative 17. Obviously, that's not a true statement, therefore that point is not on the line. When asked to graph a linear function, there are several methods you could pick from. You could make a t-table and pick values for x and solve for the corresponding y values, or you could make sure your equation is in slope and intercept form and use those two values to sketch the graph of your line. Slope-intercept form, if you recall, is y equals mx plus b. So graph each line. In that first equation, y is already by itself. It's in slope-intercept form. Y equals 2/3 x minus 4. The number that's in front of the x is the slope of the line. So the slope is positive 2/3. That means we'll count up 2 and over 3. And it'll look from left to right like you're going up a hill. The part that's after is the y-intercept, and that'll be our start point. Now that should be an ordered pair, and that would be 0, negative 4. On the graph, that's where we'll start. Now remember, the x-axis goes left and right, the y-axis goes bottom to top. So negative 4 would actually start on that y-axis. The slope is positive 2/3, meaning we'll count up 2 and 3 to the right. There's another point that's on that line. Continue that pattern all the way to the edge of your graph, as far as you can go. And then we'll do the exact opposite. Instead of counting up and over, I'm going to count down 2 and 3 to the left. That should also be on the line. Down 2, 3 to the left, down 2 and 3 to the left. Look at all those points. They appear to be collinear. Go ahead and draw a line that goes all the way through your graph from edge to edge. And there's your first linear function. Now the second example we'll still be able to graph, but it isn't in slope-intercept form yet. So if you want to make a table, you're welcome to do that. However, it should be pretty easy to get y by itself. If we subtract 4x to the other side and put it in slope-intercept form, we would get y equals negative 4x plus 3. So now our slope is negative 4. Which means negative 4 over 1. From left to right, you'll be going downhill. And our start point, our y-intercept, is positive 3. Pause the video and graph that line all the way through the graph. Then press play and see how you did. You should have a very steep line when you're done. From left to right, you're going downhill, and you cross the y-axis at 0, 3. Our last portion of the lesson will be identifying intercepts of a graph. Keep in mind you can have an intercept that's an x value or a y value, looking at where it crosses the x or y axis. In that first example, notice it doesn't cross the x-axis at all. There are no x-intercepts and one y-intercept right there on the coordinate system. In that next example, notice it crosses the x-axis up to, actually 3 times, and only one y-intercept. Here's an x, and an x-intercept, and the y-intercept matches right at 0, 0, right at the center. Sometimes your graph can be reversed where there's only one x-intercept, but more than one y-intercept. So 2 y-intercepts on the vertical axis and 1 x-intercept. And then there are occasions where there are no intercepts at all. So literally we're going to just look at our pictures and decide the x and y intercepts for each equation. Our first equation is y equals x cubed plus 1. This is a cubic function. Because of that, it could cross the x-axis 3 times total. But if we look at our graph, notice it only has one x-intercept. And if we write that out, that's at -1, 0. If we look at the y-axis, it has one y-intercept as well. And that's at 0, +1. Take a look at one more example. Now we have a quadratic function because the biggest term is an x squared term. Quadratic. Taking a look at this picture, now we have 2 x-intercepts. And if we count over, it looks like -5, 0, and 0, 0. Looking at where it crosses the y-axis, there's only one. And that matches at 0, 0. And that's lesson 1.1. Please watch this and have it ready for class on Monday.